All right. Hello. Welcome. And in today's, we're gonna talk about scientific notation, simplifying radicals, and also the absolute value. Let's get started. So, what is a scientific notation? So, scientific notation is where if you have a huge number, you make it into a compact form, so it is easier for us to compute or, to um, calculate. For example, 200 to 2 billion, let's say. Now, this is a large number, right? So if we want to compact it to make it easier to calculate, if we multiply it to another number or divide, we can make this into in scientific notation. So the scientific notation for this is 2 times 10 to the power of 9. So a scientific notation is in the form of a times 10 to the power of k, where our coefficient a here must be in between 1 and must be strictly less than 10. Alright? Okay. Now, another example. Let's say 273,000 times 47,000. Now, let's say 2,000. Okay. What will be the result if we put in the scientific notation? In the scientific notation, it will be 273. Let's say this first. So we convert the zeros into power of 10. So 10 to the power of 3 zeros. Okay, 273 times 10 to the power of 3 times 2 times 10 to the power of 3. And notice that 273 is already greater than our inequality here, which is a. So what we do here is we must add a decimal. If we add a decimal, let's say 47, we add a decimal here, 4.7. It's not the same, right? So we must times 10. So it will be the same as the result in the left, the number of 1. Again, let's say 572. We must make it in between 1 and 10. So it's 5.72 times what to make it the same as the left side? 10 to the power of 2. Okay. Now, this will be what? 2.73 times 10 to the power of 2, right? And then times 10 to the power of 3 times 2 times 10. 2 times 10 to the power of 3. And what will be the result of this? 2.73 times 10 to the power of 2 times 10 to the power of 3. Remember, if we multiply with the same base, different exponent, that means we add the exponents. So we have 10 to the power of 5 times 10 to the power of 3 times 2. We have, let's collect them. So 2 times 2.73 times 2, and then 10 to the power of 5 times 10 to the power of 3. This would be 5.46 times 10 to the power of 8. All right. That's the result of this. And now let's another example. Let's say we have like 420,000 times 74 7,400 over 0.024. Right. In the numerator, we have to convert this into the scientific notation. So we have 420,000, so it will be 42,000. Well, I mean 42 times 10 to the power of 3. What? How many zeros? 1, 2, 3, 4. 4 4 times 7,400 would be 74 times 10 to the power of 2 divided by, okay, 0.024. How do we make this into the scientific notation? Remember that if we have 0.01, it's the same thing as 1 over how many? 100, right? If we want to convert into powers, that means 10 to the power of 2. And remember that the form that 10 a to the power negative k or negative 1, it must be 1 over, so a to the power of negative k, that must be 1 over 1 over k. So this will be 10 to the power of negative 2. Okay? Okay, now you can do this easily. This will be 24 over 1000, right? That means 24 times 10 to the power of negative 3. Okay, we multiply the numerator. So if we have 10 to the power of 4 times 10 to the power of 2 will be 10 to the power of 6 over 10 to the power of negative 3. Let's collect them. Times 42 times 74 over 24. 42 times 74 over 24. This will be, okay, if we have an, again, negative power at the bottom, if we switch it to the numerator, then it will be a positive. So 10 to the power of 6 times 10 to the power of positive 3 will be 10 to the power of 9 times 242. 42 times 74. Let's use the calculator for this one. That would be 129.5. 129.5 times 10 to the power of 9. Alright. This is still not in the scientific notation because it's still larger than 10. So we must make it in between 1 and 10, or equals to 1 also. So how do we do this? We times this. We make this into 1.295, right? Okay. 1.295. That means we need to times it by 10 or 100, right, to make it equal to the 1.129.5. So times 100, which is 10 power of 2, and then times 10 to the power of 9. Hence what we get here would be 10 to the power of 11, right? So 1.295 times 10 to the power of 11. We can round this off to 1.3 times 10 to the power of 11. Okay, that's for the scientific notation. Next, we're going to talk about simplifying radicals. So, if we have like square root of something, square root of, let's say, 4 is equal to 2, right? If we have square root of, let's say, 8, well, it's not a perfect square, so we cannot really do anything. But if we make it this like this, so 2 times 4, oh look, 4 is a perfect square. And if you remember that square root of a times b must be square root of a times square root of b, okay, that means this must be square root of 2 times square root of 4. That would be 2 root 2. Okay, so to simplify radicals, there must be non-perfect squares inside of the square root. The expression inside of the root is called a radicand. Okay, another example, if we have square root of, let's say, 27 over square root of, let's say, 18, how do we simplify this? Okay, we convert this. So what times what equals 27? 3 times 9, right? Divided by, and then square root of what times what equals to 18, which is 9 times 2. Okay, 9 is a perfect square, so we can make this into root 3 times root 9 over root 9 times root 2. What we get is 3 root 3 over 3 root 2. Since the numerator and the denominator 3 are 3's and it's multiplication, we can scratch them. What we are left with is square root of 3 over square root of 2. Okay, since we can't have any radicals in the denominator, we must times by itself. So square root of 2 times square root of 2. So root 3. Remember that square root of a, yeah, square root of a times square root of b must be square root of ab. That means square root of 6 over 2. Remember, if root a times root a, it must be a. So this is 1 over 2 root 6. Okay? Another example, a final example would be, let's say, if we have, okay, so in the numerator, what times what equals to 98? Would that would be 9. So 98, if we make the factor tree, that would be 2 times, it's 2 times 49, sorry, 49, 7 times 7. Then the result would be square root of 7 squared times 2, square root of 7 squared times 2, and then add by square root of 147 is 7 squared times 3, okay, and divide by 7. So using the property, we will have 7 root 2 plus 7 root 3 over 7. What we get is 7 times root 2 add by root 3, okay, over 7. We cancel those and left us with our final expression, which would be root 2 plus root 3. Okay, that's simplifying radicals. And next, we're gonna go through absolute value. So what's an absolute value? If we have a negative number like negative 2, if we take the absolute value, it will be 2. If we have an expression, let's say negative 7 plus 3, take the absolute value, this will be 7 plus 3, which is 10. So let me write down the properties. The symmetric property of absolute value would be negative a is equals to a. That means a must be greater or equal to 0, because there's no way, if you take an absolute value of a negative number, it will be another negative number. Okay, the absolute value of a is absolute value of a. Okay, absolute value of a, um, times 0 must be still 0. Of course, everything times 0 is 0. So um, the distributive property of, or the multiplication property of absolute value is absolute value of AB is absolute value of A times absolute value of B. Absolute value, the quotient property, which is absolute value of A over B, it must be absolute value of A over absolute value of B. And I almost forgot that the square root, the absolute value of A, it must be root A squared. Okay, that's the absolute value. If we can turn absolute value into a radical expression. And then the power identity, which what which is absolute value of a to the power of n, is this would be the same thing as absolute value of a to the power of. Okay, that's the properties of absolute value for now. There's also actually distance property, but that will be, I'm going to talk about it later in the future episodes. Okay, let us go through the examples. Okay, um, if we have absolute value of negative, let us try to use the expressions here. So absolute value of negative 8 will be in absolute value of negative 4 times 2, right? Times absolute value of negative 14 will be negative 7 times 2 over 2. So we can, using the quotient rule, we can distribute the absolute value. So absolute value of negative times 2 times absolute value of negative 7 times 2, absolute value will be absolute value of 2. Now we can use this property, the multiplication. would be absolute value of negative 4 times 2, absolute value times absolute value negative 7 times 2, negative 7 times 2, absolute value over absolute value of 2. Okay, we can use this property written that here. So this will be absolute value of negative 4 times 2 times absolute value of negative 7 times 2, absolute value of 2. And then the result would be negative absolute value of negative 4, that's negative 4 absolute value of times absolute value of 2 times negative 7 times absolute value of 2 over absolute value of 2. This will be okay. We can cancel either one of the twos. We will have this, and then we have 4 times 7 times 2, since the value of a positive must be still be a positive. This will be 4 times 7 will be 28. 28 times 2 will be 56, I believe. Yeah, 56. So that's the result for this. I mean, you can that directly simplify this. This is 8 4, so 4 times 14, that will be 56. So this will be useful if there's like a question that asks if there's an absolute value expression, and then you need to turn it to, let's say, a plus b something y, and then you need to find a plus what's the value of a plus b over a minus b. Let's say there's still absolute value of a and absolute value of b. Then this will be useful for the question like that would be in the final unit. That would be the unit exercise at the end of the unit. So that's for the absolute values. Or the final example, I'm gonna use this um, rule. So let's say if you have, let us simplify this. Absolute value of 4 will be just 4. So 4 times root a squared, it's the same thing as absolute value of a over absolute value of a times b, absolute value of a times absolute value of b, minus by what this is supposed to be multiplication times by absolute value of b. This cancels out. What will we get is just 4 over absolute value of b times absolute value of b. So remember that absolute value of b is something as square root of b squared, right? So since square root of something times square root of the something which is the inside is the same, it will be itself. So this will be 4 over b squared. Again, square root of b squared times square root of b squared. So this is our final answer of the simplified version. Okay, I think that will be it for today. So in this video we have covered scientific notation and simplifying radicals and absolute value. So that's it for this video. Well, I hope to see you on the next video. If you enjoyed this, please like and maybe share. Hopefully my explanation is good, and yeah, thank you. See you next time.